Well, welcome back to another introduction video for a new type of FRQ problems. We just finished type 4, which was graphs. We're going to move into type 5 now, which is rate in, rate out problems. That's how I classify them. And so that means we're going to be given different functions, maybe tables, maybe graphs, who knows. But it's all going to be talking about how rates impact an amount of something. And so interpreting calculus in real life. And so the problems we're going to focus on are listed here. Our first one that we're going to do as a group, as a class, for our introduction will be 2013 number 1. This is a calculator problem, and I will say that more often than not, rate in, rate out problems will be calculator based because they're normally written as functions. So let's go ahead and take a look at 2013 number 1. It says, on a certain workday, the rate in tons per hour at which unprocessed gravel arrives at a gravel processing plant is modeled by G of t. So notice before we go any further, it says here that G of t is a rate, and it gives us our units, a rate in tons per hour. So we want to keep that in mind, that G is a rate in tons per hour. All right. At the beginning of the workday, and the beginning of the workday is t equals 0, the plant has 500 tons of unprocessed gravel. So this is an initial condition. It's hidden in words, but we have an initial condition for the amount of gravel of 0, 500. It says during the hours of operation, from 0 to 8, the plant processes gravel at a constant rate of 100 tons per hour. So what I want to notice here is this, that it says that G of t is the rate at which unprocessed gravel arrives. So G of t is the rate in, and then down here it says the plant processes the gravel. Well, if the gravel is processed, that means it's no longer unprocessed. So it is processing at a rate of 100 tons per hour. So again, this is a rate here. This is a function, a constant function, but it's a function that represents the rate at which gravel is being processed. In other words, it's the rate out. So G of t is the rate in, and 100 tons per hour is the rate out. So keep that in mind as we go through this. All right, part A, it says find G prime of t. Well, that's pretty straightforward. This is a calculator problem, so we do not have to actually take the derivative on our own. We can rely on our calculator to do the work for us. So the only thing we have to do is type the function, and we should do this at the very beginning. Type this into our y list. So we're just going to say G prime of 5 is equal to whatever we get when we take the derivative evaluated when t equals 5 with our calculator. We do not have to show the work of the derivative unless the problem specifically says so. And I would advise not to do that because you're prone to make mistakes. Okay, just use your calculator. So we get negative 24.588, and then it says use correct units and interpret your answer in the context of the problem. Well, first of all, using correct units, if G is tons per hour, that means G prime is going to be tons per hour squared. Okay? So this is, if it was particle motion, it would be an acceleration. But we don't use the word acceleration because we're not talking about movement of objects here. We're talking about the amount of gravel being processed. So we would say this, since G is a rate, G prime is a rate of a rate. So we would say the rate at which unprocessed gravel arrives, let me take a step back here. The rate at which unprocessed gravel arrives, that statement is a G statement. The rate at which unprocessed gravel arrives, in other words, G, all of this can be rephrased by using just G. G is decreasing Why is g decreasing? G is decreasing because g prime is negative. So g is decreasing at a rate of 24.588. Now we put in our units. Our units would be tons per hour squared. And then we have to include our time, which is at t equals 5 hours. So again, you need four things in your interpretation. You need what it is, so the rate at which unprocessed gravel arrives is decreasing, and then, sorry, what it is. Then we need to say, sorry, let me rephrase that. The rate at which unprocessed gravel arrives is decreasing at a rate, that's what it is. Then the answer, 24.588. In fact, the decreasing and the 24.588 is part of that answer, right? And then you need your units, tons per hour squared, and then you need your time that it took place, or your time interval, which is t equals 5 hours. You would get 1 point for g prime of 5, so 1 point for getting this numeric answer, and then 1 point for your interpretation. Again, all four things have to be there for a correct interpretation. That's a little bit tricky to interpret, this particular one, because it's a rate of a rate. But get used to that. That pops up more often than you think. For part B, it says find the total amount of unprocessed gravel that arrives at the plant during the hours of operation on this workday. So we are just looking for the amount of unprocessed gravel that arrives. So we don't care about how much, in this case, how much was processed. We don't care about how much we started with. All we care about is how much arrived. Well, if g of t represents the rate at which it arrived, then the amount that arrived would just be the integral of g over 0 to 8, because it says during the hours of operation. And so we type that into our calculator, and we end up with 825.551. And then that would be tons. So that's our answer for part B. And you would get 1 point for the integral. So having the correct expression here, the integral from 0 to 8 of g of t dt, and then 1 point for your answer for part B. All right, looking at part C now. Part C, it says, is the amount of unprocessed gravel at the plant increasing or decreasing at t equals 5? Now this is where the rate in and the rate out come together. Okay? If we are, I'll just give you an example. If the rate at which gravel is arriving is 200 tons per hour at a specific time, and we are processing it, in other words, we're getting rid of it at a rate of 100 tons per hour, then our rate in is greater than our rate out, which would imply the amount coming in is greater than the amount coming out, or going out, which means the amount is increasing. Okay? In other words, another way to look at this is, how do we know a function is increasing or decreasing? We know a function is increasing or decreasing when its derivative is positive or negative. So we actually have to have a function that represents the overall rate if you do it that way. Let's take a look at how I did this. I figured out what g of 5 was. G of 5 is 98.141, so this is the rate at which gravel is coming into the plants. So it's coming in at a rate of 98 tons per hour. And we know that it's going out of the plant, or it's being processed at a rate of 100 tons per hour. And so we can see that the rate in is less than the rate out. And if the rate in is less than the rate out, that means the amount is decreasing because obviously the rate in is less than the rate out. The other way of looking at this, and I didn't do this here, but I can, we can come up with an overall rate, and I'll just name it R of t. So the overall rate is going to be equal to g of t minus 100. Okay, g of t minus 100. That's the overall rate. And basically, this is the rate in and the rate out. This is a general form. The overall rate is equal to the rate in minus the rate out. Forgive my handwriting, I'm not using lines to follow or anything like that, so it's a little sloppy. But remember, if the overall rate is positive, that means the amount is increasing. So let me write that down. If, let's see, let's go over here. If r of t, or r of 5 in our case, is greater than 0, then we are increasing. Okay? If r of 5, the overall rate, if that's how you define it, is less than 0, then the amount is decreasing. And so we can figure that out pretty easily by saying, okay, the overall rate, r of 5, is going to be equal to g of 5 minus 100. And so we know that g of 5 is what? G of 5 is 98-ish minus 100. And so we can see that r of 5 is actually a negative number. And as a result of that, since r of 5 is negative, then we can see that the amount is actually decreasing. So that's another way of looking at it. That's not how I did it, and that's okay if you did it that way. Let's go ahead and take a look at the points here. You would get 1 point for comparing g of 5 to 100. So that's what I did here. Or you would get 1 point for showing that g of 5 minus 100 is negative. And then you would get 1 point for your conclusion that the amount is decreasing as a result of that. Okay, for part D, it says, what is the maximum amount of unprocessed gravel at the plant during the hours of operation on this workday? So this is looking for the absolute maximum. The way we go about finding an absolute maximum is finding all of our critical points, and evaluating the amount at each of those critical points. That's probably the best way of doing that. So again, we need to figure out a rate, an overall rate function. So here's where I kind of did that. I said let r of t equal g of t minus 100. This is the overall rate. So the rate in minus the rate out. And so since the overall rate is now defined, how do I figure out a max or a min? I set the rate equal to 0. So I set that equal to 0. So 0 equals g of t minus 100. And there's a couple different ways of doing this with your calculator. You could add 100 to both sides and look for the intersection between g of t and 100. Or you can type this into your y-list as whatever the function is, minus 100 more, and then find the zeros. But the bottom line is you get t equals 4.923. Now, you have two other critical points in this case because you have endpoints here. We know that we had a certain amount of gravel. We had what, 500? We had 500 tons of gravel at the beginning of the day. So when t equals 0, we had 500 tons. We don't know how much we ended with, and we don't know how much we have at this point. So we have to figure out the amount at each of those three critical points. So our critical points are 0, 4.923, and 8. And so we're going to find the amount by a position equation if we're going to relate it to particle motion. So it's going to be the amount at 0 is equal to the initial condition plus the integral of the rate. So at 0, this one's easy. We started with 500 plus the displacement here. The displacement is the integral of the overall rate, and we define the overall rate to be g of t minus 100. So 500 plus the integral from 0 to 0 of g of t minus 100 is just 500. Then the next one would be 500 plus the integral from 0 to 4.923 of g of t minus 100 dt. And then just typing that in your calculator, you get 635.376. And then our last one would be 500 plus the integral from 0 to 8 of g of t minus 100 dt, which is 525.551. So the maximum amount of unprocessed gravel is 635.376 tons. Points for this, you would get 1 point for setting G of T minus 100 equal to 0, like this. You would also get the same point if you set G of T equal to 100. That would give you the 1 point there. You would get 1 point for your answer, so 1 point for the 635.376 tons. And then you get 1 point for the justification. In this problem, the justification actually comes from finding the amount of gravel at all your critical points. So this is your justification here. Okay, this problem is a little bit difficult to fully grasp. So please, if you have any questions on this, let me know, and I will do my best to clear up any misconceptions or misunderstandings that you might have. With that said, we are now done with our introduction, so that means it's your turn to do a problem to see how you fare. We just did 2013 number 1, so I want you to do 2014 number 1. This is a calculator problem. So set your timer for 10 minutes and see how you fare, and then grade yourself in comparison to our next video.